Hi friends, I am Magic Sir of Mathematics with Magic Methods. Today, Magic Sir will help you to improve your knowledge of trigonometry. I will never prefer any shortcut without understanding the concept of trigonometric identities. So here is no drama, no tricks, only pure mathematics. In this video, we will verify these four trigonometric identities one by one. We will use algebraic formulas which you have studied in earlier classes. Let us take the first example. Here, left hand side is more complicated. Let us try and see what we could do with left hand side. We know that cot theta is equal to 1 upon tan theta. So replace cot theta with 1 upon tan theta. See the animation. Again, replace cot theta with 1 upon tan theta. How can we simplify the first fraction? See the speech bubble. Suppose we take x equal to 1, y equal to tan theta and z is equal to 1 minus tan theta. Then our first fraction is x upon y and whole divided by z. So we can write x upon y is divided by z. That is x upon y times 1 upon z. It is equal to x upon yz. So our first fraction is x upon yz. So LHS is equal to 1 upon tan theta into 1 minus tan theta. Now look at the speech bubbles. If we take tan theta equal to t, then the denominator is 1 upon t minus 1, which is equal to 1 minus t upon t. Again replace t with tan theta. So the second fraction is tan theta divided by 1 minus tan theta upon tan theta. How can we simplify the second fraction? Look at the speech bubbles. Suppose we take tan theta is equal to p, 1 minus tan theta is equal to q, and tan theta is equal to r. Then our second fraction is p divided by q upon r. It is equal to p times r upon q is equal to pr upon q. So we can write p divided by q upon r is equal to pr divided by q. So the second fraction is tan theta into tan theta upon 1 minus tan theta is equal to tan square theta upon 1 minus tan theta. Friends, how can we subtract two fractions with unlike denominators? Let us find the LCM. LCM of tan theta into 1 minus tan theta and 1 minus tan theta is tan theta into 1 minus tan theta. That is LCM equal to tan theta into 1 minus tan theta. A small adjustment is required to obtain the LCM. It can be achieved by multiplying the denominators of the first term by 1 and the second term by tan theta. Now we can combine two fractions into one with denominator as tan theta into 1 minus tan theta. Here 1 into 1 is equal to 1 minus tan theta into tan square theta is equal to tan cube theta. For convenience, we may rewrite this step again, that is LHS equal to 1 cube minus tan cube upon tan theta into 1 minus tan theta. Now apply the formula of a cube minus b cube is equal to a minus b into a square plus ab plus b square. Suppose a equal to 1, b is equal to tan theta, then a minus b is equal to 1 minus tan theta, a square equal to 1 square, a into b equal to 1 into tan theta, and b square equal to tan square theta. So our LHS is equal to 1 minus tan theta into 1 square plus 1 into tan theta plus tan square theta upon tan theta into 1 minus tan theta. Here 1 minus tan theta cancels out, leaving us with LHS equal to 1 square plus 1 into tan theta plus tan square theta upon tan theta. This can be written as 1 upon tan theta plus tan theta upon tan theta plus tan square theta upon tan theta. We know that 1 upon tan theta is equal to cot theta. Tan theta upon tan theta is equal to 1 and tan square theta upon tan theta is equal to tan theta. So our LHS is equal to 1 plus tan theta plus cot theta. Comparing with RHS of the equation, we can say that right hand side and the left hand side are the same. In the second example, the left hand side is more complicated. Here LHS equal to, in the first bracket, cosec theta minus sin theta, in the second bracket sec theta minus cos theta, and in the third bracket tan theta plus cot theta. Let us recall the trigonometric identities for cosec theta, sec theta, tan theta and cot theta. We know that cosec theta equal to 1 upon sin theta. Look at the first bracket. We can replace cosec theta with 1 upon sin theta. In the second bracket, sec theta equal to 1 upon cos theta. So we can replace sec theta with 1 upon cos theta. And tan theta is equal to sin theta upon cos theta. And cot theta equal to cos theta upon sin theta. So we can replace tan theta with sin theta upon cos theta and cot theta with cos theta upon sin theta. Let us simplify the each bracket separately. So sin theta into sin theta is equal to sin square theta. So in the first bracket 1 minus sin square theta upon sin theta. Similarly, cos theta into cos theta equal to cos square theta. So in the second bracket, 1 minus cos square theta upon cos theta. And sin theta into sin theta equal to sin square theta plus cos theta into cos theta equal to cos square theta and cos theta into sin theta equal to cos theta sin theta. So in the third bracket, we have sin square theta plus cos square theta upon cos theta into sin theta. Again, Recall the Pythagorean identities. 1 minus sine square theta equal to cos square theta. So we write cos square theta in the place of 1 minus sine square theta. Similarly, 1 minus cos square theta equal to sine square theta. So we write sine square theta in place of 1 minus cos square theta. And sine square theta plus cos square theta equal to 1. So we write 1 in place of sine square theta plus cos square theta. On multiplying brackets with each other, we get cos square theta into sine square theta into 1 is equal to cos square theta into sine square theta, and sine theta into cos theta into sine theta is equal to sine square theta into cos square theta. Here cos square theta into sine square theta cancels out, leaving us with LHS is equal to 1. Comparing with the right hand side of the given equation, we can say that left hand side is equal to right hand side. Look at the example 3. Let us take the left hand side for simplification, as it seems very complex than the right hand side. Look at the left hand side. We need to figure out how to proceed further. Now recall the Pythagorean identity that can replace 1. We have three formulas. First, sin square theta plus cos square theta equal to 1. Second, sec square theta minus tan square theta equal to 1. And third, cosec square theta minus cot square theta equal to 1. Which formula is appropriate to use? It is cosec square theta minus cot square theta equal to 1, or 1 is equal to cosec square theta minus cot square theta. So we can replace 1 with cosec square theta minus cot square theta. See the animation. Now apply the formula a square minus b square is equal to, in the first bracket, a plus b, and in the second bracket, a minus b. Let us suppose a equal to cosec theta and b is equal to cot theta. So a plus b is equal to cosec theta plus cot theta, and a minus b is equal to cosec theta minus cot theta. Hence, cosec square theta minus cot square theta equal to cosec theta plus cot theta into cosec theta minus cot theta. Note the changes in the red color brackets. Here, cosec theta plus cot theta is a common factor. So taking cosec theta plus cot theta common, we get left hand side is equal to cosec theta plus cot theta into second bracket 1 minus, from the second bracket, cosec theta minus cot theta, whole upon 1 minus cosec theta plus cot theta. By simplifying, we get left hand side is equal to cosec theta plus cot theta into bracket 1 minus cosec theta minus again minus cot theta equal to plus cot theta, whole upon 1 minus cosec theta plus cot theta. Now keep an eye on the other side and work as needed. Here 1 minus cosec theta plus cot theta cancels out, leaving us with left hand side is equal to cosec theta plus cot theta. Comparing this result with the right hand side of the given equation, we can say that both the left and right sides are equal. Example 4. Tan square theta minus sin square theta is equal to tan square theta into sin square theta. Let us take the left hand side of the equation, that is LHS equal to tan square theta minus sin square theta. We know that tan square theta is equal to sin square theta upon cos square theta. So we can replace tan square theta with sin square theta upon cos square theta. Here sin square theta is a common factor. Now see the animation. Here we can observe that sin square theta is the common factor. Taking sin square theta common, we get LHS equal to sin square theta into bracket 1 upon cos square theta minus 1. We know that 1 upon cos square theta is equal to sec square theta. So we replace 1 upon cos square theta with sec square theta. Therefore LHS equal to sin square theta into sec square theta minus 1. Again, recall the Pythagorean identity. Sec square theta minus 1 is equal to tan square theta. So we can write tan square theta in the place of sec square theta minus 1. Hence, LHS equal to sin square theta into tan square theta. Comparing this result with the right hand side of the given equation, we can say that left hand side is equal to right hand side.